All right, welcome everybody to Accuplacer Math Crash Course. This is day one, part one, and we've got a student with us today. This is Juliana. Say hi to everybody, Juliana. Okay, thank you, Juliana. And so for those of you watching the recording, I want to explain a little bit about sort of the philosophy of the course and kind of how we're approaching things today and for the rest of the course. So the Accuplacer Math Test, there's two ways we're going to approach these questions, and sort of two aspects of the course. And the first one is strategies. I'm going to teach you some really basic but really powerful strategies that are going to simplify the questions on the Accuplacer Math Test. And that's probably going to be the focus of the course is the strategies. And there's a way of looking at these questions that makes them a lot easier. And you don't have to know everything about math to answer these questions. You just have to know enough to find the right answer. That's kind of how I approach these questions. So don't freak out if your math level is not super high. It's not a problem. You just have to know enough to find the right answer. And then the other side of the course is sort of the math operations, which we're going to do as well, right? You're going to have to know some basic arithmetic. You're going to have to know a little bit about exponents and how to deal with variables and things like that. We'll go over that as well. But I think the primary focus of the course is thinking about the questions in the right way that are going to make the questions a lot easier. So today we're going to do a little bit of that, and we're going to do a little Accuplacer arithmetic in day one of the course. That's kind of the focus of today's course. And then we're going to bump the level of difficulty up kind of as we go through the course. Does that make sense, Juliana?
Yes.
Okay, good. All right. So I want to start, before we jump into the questions, and I do have a question up on the whiteboard here we're going to get to, but I want to read the rules for Accuplacer Math, specifically rule 1 and 2. Can you see those up on the screen?
Mm-hmm.
Okay, so go ahead and read rule number 1 for me, please, on my rules for Accuplacer Math.
Use basic logic and estimation whenever possible.
Yeah, there's a lot of questions where you don't have to carry out a specific operation. Like, you can just kind of look at the answer choices. And if it doesn't work in the real world, or if it just doesn't make logical sense to you, you can probably eliminate that answer choice completely. It's got to work. It's got to work within the real world, and you can use basic logic. You can use common sense on these questions, and that's really good news. You don't necessarily have to know what to do with the numbers, or do I multiply, divide here? Just think about it logically. And then I think we're going to see some questions today where that's going to apply. And then go ahead and read the second rule for me as well, please.
Use the process of elimination to test answer choices whenever possible.
Yeah, and this is very powerful. You actually don't need to know how to solve any of these questions to get them right. You don't. If you can eliminate the obviously incorrect answer choices. And so we're gonna focus on both of those rules using basic logic and then using process of elimination to eliminate incorrect answer choices. We're going to find the right answer. We're also going to go over some of the steps. I want to teach you kind of the right way to do it and how to solve these, using the steps. But those first two rules are so powerful, and if you can learn to approach this test from a perspective of kind of basic logic, the whole thing opens up and it becomes a lot easier. So we've got a question here on the whiteboard. Question number 8. Now, this is straight from the Accuplacer, Next Generation Accuplacer questions released by the College Board. These are the makers of the test. So these are the kinds of questions that you're going to see on the Accuplacer. Now, one quick note about the Accuplacer, they call it an adaptive test, which means that if you're getting the easier questions right, they'll throw some harder questions at you. And but if you get some of the harder questions wrong, they're going to start throwing some of the easier questions at you. So I don't know if they're going to start off with one quite this easy, but this is the kind of question that potentially you could still see on the test. It's from the College Board, the guys that make the test. Go on to read question number 8 for me, please.
What is 1,582 plus 761?
Okay, thank you, Juliana. All right, so, okay. Before we talk about adding these together, okay, which we're going to do here in just a minute, we're going to go through all the steps. I want you to think about this for just a minute from a perspective of basic logic and estimation. Okay, if you're going to estimate roughly how much 1,582 plus 700 whatever is, what is that going to be roughly?
At least 2,300.
Yeah, at least 2,000. It's got to be over 2,000. Can we agree on that?
Mm-hmm.
It's got to be over 2,000.
Yes.
And that's easy, right? Just kind of looking at it from a perspective of basic estimation. It's got, if you got 1,500 something and 700 more, it's going to have to be over 2,000. There's no way around it. Look at the answer choices on this question. It's almost laughable. Okay, are you looking at them now?
Yeah.
What answer choices can we absolutely eliminate?
A and B.
Yeah, A is gone, right? Think about that for just a minute. That's less than 1,500. Significantly less. And we're adding. So it's got to be bigger than 1,582, not less than. A is ridiculous. What else can we eliminate?
B. B is also ridiculous.
Absolutely. That's ridiculous. What about C?
Yeah, we can eliminate that.
Absolutely, right? And so we can confirm easily it's got to be something like answer choice D. And it is answer choice D. Okay? And that's without doing a single step, without doing a single operation. Okay? You can just kind of look at that and feel that one out and find the right answer. Does that make sense, Juliana? Okay.
Yes.
Okay. Now, I do want to go through the steps, right? Because you could see a question like this, and now, sometimes they're going to give you a calculator, like that'll pop up on your screen on an Accuplacer question. Sometimes you won't have access to it. I'm guessing this is the kind of question where you wouldn't have access to the calculator, right? Otherwise, you're just punching it in and find the answer, and it's really easy. Again, we made it really easy just thinking about it logically, but I want to go through the steps here as well. Can you kind of work this out on the whiteboard and show us how you can find the answer to this question going through the steps?
Yes.
Okay. So this is kind of like, middle school arithmetic here. You're just lining everything up. Very nice. I like the color choice.
Yes, I want to switch it up.
Nicely done. So you got to line everything up. And you're going to line it up on the right-hand side, right? Because this 1 here in 761 is in the ones place, and this 2 in 1,582 is also in the ones place. You got to line everything up in the right place. As long as you do that, you're just adding down. Absolutely. That's 14, so put the 1 in the next place. I'm going to stop you. Is that a 2 or a 3?
Oh, that meant to be a 3.
Okay, yeah, right.
My bad.
Yeah, you're good. You're good. So 5 plus 7, right, would be 12, but there's that 1 that we carried up from the 8 plus 14, absolutely. 2,343, so we can confirm it is indeed answer choice D. Any questions about that?
Nope.
Okay, super easy. I don't think it gets much easier than that on the Accuplacer, but still it's a good review, kind of adding large numbers, so I think it's worth going over. Any questions at the moment?
Nope.
All right, let's rock and roll. Go to the next question. Let me see here. All right. Question number 3. Bump up the level of difficulty here just a little bit. Go ahead and read question number 3 for us, please.
What is the value of 4 over 10 plus 3 over 100?
Ooh, okay. What is the value?
Good old fractions.
Yes, fractions, right? And how do you feel about fractions, Juliana?
I mean, sometimes it just depends on the fraction problem.
Okay.
But
Yeah. Well, I tell you what. Let's approach this one. Not so much from the perspective of operations, but let's approach this one from sort of the basic logic and estimation perspective. Does that make sense?
Yes.
Okay. All right. So we've got 4/10 plus 3 over 100. Okay. What is 4/10 roughly equal to? 4 over 10 roughly equal to?
It's less than a half.
It's less than a half. Is it much less than a half or just a little bit less than a half?
Just a little bit.
Just a little bit less than half. And think about that for a minute, what 4 over 10 means, right? It means you've got, out of, if you got like a piece of pizza with 10 slices, right? You've got 4 of those 10 slices. You have almost half the pizza. Does that make sense?
Yeah.
And I love thinking about fractions in concrete terms. A lot of students get overwhelmed with fractions, so they're focused on the operations. But you don't have to think in those terms. I think you can focus a lot on sort of basic logic and estimation and really understand what a fraction means. And if you're thinking in those terms, this question gets a lot easier, okay? 4/10 is like almost a half, a little bit less than a half. Just a little bit less than a half. Yeah, 4 slices out of 10 on a piece of pizza. Okay, now, what about 3 over 100? What is that roughly equal to?
That's a very small.
It's a very small number, right?
Yeah.
That's a very small number. Let's recognize that. That's very small. It's not 0.
Yeah.
But it's close, right? It's not much more than 0, right? And think about it again. If you've got like 100, there's like 100 cents in a dollar, right? You've got 3 of those cents out of 100 cents in a dollar. It's not much money, right? Or if you want a piece of pizza, split it into 100 slices, right? Or a giant pizza, right? 100 slices, right? Those would be some pretty tiny slices. Can we agree?
Yes.
Okay, very tiny slices. And you've only got 3 of those tiny slices. So you've got like 3 slivers of a pizza. It's not much pizza.
That's so sad.
Yeah, that is very sad. Not much pizza for you, right? But compare that to like 4/10 of a pizza, right? That's 4 out of 10 slices. That's still a healthy amount of pizza, just a little bit less than half. Okay, but 3 out of 100 is almost nothing. You're getting slivers. Okay? All right, so what do you think, if you're just going to estimate what that value is close to, what do you think it's close to? Are we talking more than half? Less than half?
Yeah.
You think it's more than half?
A little bit less than half, actually.
Still a little bit less than half, right? Because 4/10 is less than half. Not a ton less, but it's less. But 3/100 is almost nothing. Does that make sense? It's almost nothing. So it's just going to be it's still going to be a little bit, it's going to be more than 4/10, but it's going to be a little bit less than 1/2. Does that make sense? Okay, let's look at the answer choices. We want an answer choice that's a little bit less than half. A little bit less than half. And let's focus on, primarily here, on the process of elimination. Because I think there's 2 answer choices that are pretty reasonable, just kind of looking at them, that look like they're a little bit less than half. But there's 2 that aren't close to less than half. What answer choice, if you're going to eliminate some answer choices, what answer choices, Juliana, would you eliminate?
B and D.
You'd eliminate B and eliminate D. Let's talk about D first. I agree. Why would you eliminate D?
Because it's 1/10, and that's more than 100.
What do you mean it's more? It's 1/10. What do you mean by that?
That's just the 110. That's just adding the 10 and the 100.
That's it. Now, okay, and you're absolutely right, and that's a bad math operation, right? When you're adding fractions, you can't just add the denominator. In fact, you don't add the denominators. You can't do that. We're going to talk about why here in just a moment. But again, I want to think about the weight of the values. We're looking for an answer that's a little bit less than half. Is D, answer choice D, 7/110? Is that a little bit less than half? No.
That's like a very little amount.
That's small. That's like less than 1/10. Yeah. Like that's small. That's not much. 7 things out of it. Again, you've got a pizza you split into 110 slices. Slivers! And you've got like 7 of those little slices out of 110. It's nothing. Okay, it's not half, not even close to half. Does that make sense?
Yes.
Okay, so we know it's not answer choice D. I agree with you it's not answer choice B. We're going to talk about why here in just a minute. Actually, it's the reason that you mentioned. We're going to get into more detail there in just a moment, though. What else would you eliminate, though, that's not less than half? A little bit less than half.
C.
C is not a little bit less than half, right? That's more than half. Do you understand why?
Because if it was half, it would be 5/10.
Yeah, half would be 5/10, right? You got a pizza with 10 slices. If you got 5/10, that's half of it. But you got something more than 5/10. You got 7 out of the 10 slices. You got more than half that pizza. It's almost 3/4 of that pizza. So there's no way.
Pizza.
Yeah, that's a healthy amount there. There's no way it's answer choice C. Does that make sense? So even if you're guessing at this point, okay, and it's not bad to get. By the way, like guessing, I'm a big fan of guessing on these questions, right? Like a good, solid, educated guess is great. Yeah. In fact, it's probably better than just like, oh man, I don't know those fractions. I'll just add to the numerator and denominator. Like, no. Don't do operations. Again, think in terms of logic and think in terms of the weight of the values and process of elimination. You don't even have to do the steps to eliminate C and D. You can just think about the question in the right terms and you can eliminate it. Okay? So, if you're guessing here, you got a 50-50 shot between A and B. Now, if you were going to eliminate another answer choice, which one would you eliminate?
B.
Absolutely. You can eliminate B, and why? Why?
Oh, because that's a little bit less than 50.
Well, but so is A. A is a little bit less than 50%, or a little bit less than half as well. They're close. I don't think you can estimate to determine between A and B. I think this is where we have to talk about the operations. We got to talk about adding these fractions.
Yeah.
Okay, so let's talk about adding these fractions. In order to add fractions, what do you have to do to add 2 fractions together?
You have to have a common denominator.
You've got to have a common denominator. So those of you watching the recording don't know what a denominator is. The denominator is the bottom part of the fraction. The bottom part here. 10 for 4/10 or 100 for 3 out of 100. Okay. And the guy in top is called the numerator. Okay, so I'll reference those from time to time. So we got a numerator in the top, a denominator in the bottom. We have to have a common denominator to add fractions. The denominators have to be the same. And then you just add the numerator. But here, the denominators aren't the same. So what can we do to get a common denominator here and add these fractions together? What can we do?
I would have the common denominator as 100.
As 100, yeah. And do you know what the operation is? Do you know what to do exactly to make that 100?
I would You would multiply 10 by the denominator, and you would also multiply 10 by the numerator.
Yeah, absolutely. So I'm going to show everyone kind of watch the recording here what that looks like. So let's take that 4 over 10. We got to have a common denominator. We're going to make it 100. So I'm going to take 4 over 10 here. I'm going to take 4 over 10. And I'm going to multiply it by 10 over 10. Okay, now stop and think about this for just a minute, Juliana. That parentheses means sort of multiplication. What does 10 divided by 10 equal?
1.
1. Anything divided by itself is 1. So we're not, and what's anything times 1? Itself. So we're not changing the value of 4 over 10 when we multiply it by 10 over 10. We're not changing the value. It's still the same value. Anything times 1 is itself. We're just going to change the form. Okay, does that make sense?
Yes.
All right, and we need to change the form to add these together. Now, when we're multiplying fractions, let's review that together. When you're multiplying fractions, it's different from adding. When you're multiplying fractions, you multiply across the numerator and across the denominator.
Cross multiplication.
Well, that's not cross multiplication. Is something different, which we may address later in the course. But you multiply the numerators and the denominators together when you're multiplying fractions. It's different with adding. You can't just add the numerator and then add the denominator.
Yeah.
But when you're multiplying, yes, you multiply the numerator and multiply the denominator. So what's 4 times 10?
40.
40. And then what's 10 times 10?
100.
100. Okay, I want you to stop and think about that for a minute. And just kind of feel this one out. Feel out this value. Does it make sense why 40 divided by 100 is equal to 4 divided by 10? Does that make sense?
Mm-hmm.
And if you just like again, like it's go to the pizza example. You got 100 little slices of pizza, and you had 40 of those slices. You got close to half of it, which is just like 4 over 10.
Yeah.
Okay. It just feels the same, and it is. And if you carried out the calculation on your calculator, right? If you divided 4 by 10, divided 40 by 100, you'd get the same value, right? It would be like 0.4. We'll talk about decimals here coming up in just a minute. But right, if you got like 4 questions out of 10 questions right on a test, yikes, that'd be 40%. It's the same score you'd get if you got 40 questions right out of 100 questions on a test. Okay, 40%, not great, depending on the test, but a little bit less than half. Okay, but now that we have a common denominator in 100, we can add these fractions together. So it's 40 over 100 plus 3 over 100, and when you're adding fractions, you just add the numerators. That's all you do. You leave the denominator. Please understand that. It's very important. You got to have a common denominator. Once you have a common denominator, you're not adding those together. You're just adding the numerator, the numbers on top. So what does that give us, Juliana?
43 over 100.
43 over 100. Absolutely. Which is the answer choice A. Does that make sense? Juliana?
Yes.
Yeah. Okay. Any questions about that?
Nope.
No. Another way to look at this one too, and you got to remember that they are basing some of the answer choices on common misconceptions about math. Okay. So so a lot of students think, oh, I've got a fraction, I'll just add the numerator, add the denominator. No, it doesn't work that way. But if you just know that you can't do that, then you can easily eliminate answer choice B and D as well, because they just added the denominators together, and you can't do that. So just knowing that concept, you can get rid of 2 of the answer choices without even doing the steps. Does that make sense?
Mm-hmm.
So be on the lookout for that too. Be on the lookout for answer choices that are based on common misconceptions about math. I look at it that way sometimes too. All right, let's roll.
Mm-hmm.
All right, question number 19. Ooh, this one's a little bit trickier. All right, we're bumping up the level of difficulty here. This one is a little intimidating looking. I'm not going to lie. Okay, go ahead and read question number 19 for us, please.
Which of the following inequalities is true?
Ooh, okay. Which of the following
inequalities
is true? Are you familiar with inequalities?
A little bit, yeah.
A little bit? Okay, we're talking like greater than, less than, something. So look, we've got 4 pairs of values here in the answer choices. 4 pairs of values. Okay? Mm-hmm. And we're trying to find which of those pairs of inequalities is true. Which means 3 aren't true.
Mm-hmm.
3 aren't true. And we should be able to eliminate some of those using some basic logic and basic estimation. Okay. Now, before we get fancy with these, all right, and start thinking in terms of math operations, let's focus on rule number 1 and 2. Let's focus on basic logic and estimation, right? And let's see if we can eliminate any of these obviously incorrect answer choices. Does that make sense?
Yes.
Okay. Let's go down the line here. Well, maybe before we do that, are there any answer choices, if you're going to eliminate them, that you would eliminate right off the bat that just don't look right? And by the way, we'll talk about these. This sign here means greater than. This sign here means less than. We'll get to that here in just a moment. So when you're reading, read answer choice A for us, please.
3/4 is greater than 5/7.
It's actually the opposite. That would be 3/4 is less than 5/7. And here's a trick. It's funny. I've got another math class actually that I've gone over this question before. I'd use the exact same explanation here. I turn the inequality sign into a Pac-Man. Turn it into a Pac-Man. It's like we've got 3/4 right here is less than 5/7. If you turn that guy into a Pac-Man, which I highly recommend, this goes back to middle school math for me. Right. Pac-Man wants to eat the bigger number.
Mm-hmm.
Right?
I remember this.
Pac-Man wants, it just works. I still think in these terms from time to time. Pac-Man he's always facing the bigger number. So you could read that as 3/4 is less than 5/7, or 5/7 is greater than 3/4. Does that make sense?
Yes.
Okay. But if you're starting with a 3/4, you'd say 3/4 is less than 5/7. Okay?
Mm-hmm.
All right. So is 3/4 less than 5/7? I'm not sure. I'll be honest. At the moment, I don't know.
Yeah.
I haven't seen this question in a while. I don't know the answer. I mean, we're going to find out here in just a minute. That's close. Relatively, right? They're both a little bit more than, they're both, over half. But less than 1. Let's hold off on that one. I don't know. We're going to test it here in just a minute. But I can't easily eliminate it just by feeling it out. You might be right. I don't know. Okay.
Yeah.
I don't know. But let's hold off on eliminating that one for the moment. Okay. Let's look at answer choice B.
Mm-hmm.
Go ahead and read that one for us, please.
2/3 is greater than 5/6.
Is 2/3 greater than 5/6? Maybe. This one I think we can right? This one I think we can test, and I think this one's a little more clear. Okay, and here's what I recommend doing with fractions, right? If you're considering the weight of these values or how much a fraction is or whatever. Again, let's make it concrete. You can do a rectangle or a pizza. Which one would you rather deal with, a rectangle or a pizza here?
Pizza.
You want to do the pizzas? Okay, let's do the pizza. So I'm gonna make two. I'm gonna use the circle tool here. Ooh, I'm gonna get a little fancy here. We got 2 pizzas. Okay, and roughly equal size.
Somewhat equal.
Yeah, somewhat equal. That'll work. Okay, roughly equal. And I'm going to split, so we've got 2/3. Let's make it concrete. So I'm going to split this pizza into 3 equal parts. Like a little Mercedes sign here. Hope I don't violate any copyrights there. That's 3 parts, right?
Yes.
Okay. And 2/3 would be 2 of those 3 parts, right?
Mm-hmm.
So let's shade in 2 of those 3 parts. And that's basically 2/3 of that pizza. Does that make sense?
Yes.
Okay, now we got another pizza that's got 6 slices, so I'm going to try to divide it into 6 equal slices. This is a little bit tricky, but it's doable. Okay, we've got 6 somewhat equal slices. That'll work, and we've got 5 of those 6 slices are yours. It's 5 out of 6. Does that make sense?
Yes.
So I'm shading this guy, and I think you already see where this is going now.
Mm-hmm.
Okay, look at that.
Yeah, 5/6 is greater.
This is 5/6, absolutely. This is 5/6 right here. That is definitely greater than 2/3.
Mm-hmm.
So I don't think that's a true statement. 2/3 is not greater than 5/6. Does that make sense?
Yes.
I think we can eliminate answer choice B. Again, we haven't done a math operation here. We've done no math, no calculation or anything like that. We're just feeling this out and thinking in terms of basic estimation and logic. Does that make sense?
Mm-hmm.
Okay. Let's look at, boy, I think C looks close. Let's look at D. Let's look at answer choice D next.
Mm-hmm.
I want to test that one. I think that's going to be easier to test. All right, so go ahead and read answer choice D. We're going to skip C for now.
4/5 is less than 2/9.
Is 4/5 less than 2/9?
Mm-mm.
I don't think so, right? Especially after we had sort of the experience of working on the last problem.
Yeah.
4/5 is close to 1.
Mm-hmm. 2/9 is like nothing.
And 2/9 is not much. It's not much. It's not 0, but I mean it's not much.
More than 0.
It's not a whole lot more than 0. And here again, let's make it concrete. And here let's make a rectangle. I think rectangle is going to be a little bit easier because I don't know how to split a pizza into 9 parts. So like make a rectangle or 2 rectangles here in this case, right? Roughly equal size. And the first one will split into 5 parts. And I'm gonna try here. Boy, this is like testing my artistic abilities here. I'm gonna try. So I'm splitting into 5 parts. 1, 2, 3, 4, 5. That'll work. Does that make sense?
Yeah.
And if we're talking about 4 out of those 5, we're shading in a whole lot, man. We're shading in all that. Right? That's almost all the rectangle. Well, it's 4/5 of the rectangle, right? And then let's look at 2/9. Okay, now this is gonna be tricky. I'm trying to split this in 9 parts. I'm just 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I think that actually works. Is that 9 parts?
I think so.
I think so too. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, hey, that works. All right, we got 9 parts. All right, and we're talking about 2 out of those 9 parts.
Mm-hmm.
Okay, so we're just talking like just that much, right there. That's not a whole lot, is it, Juliana?
Mm-mm.
Not even half. I think pretty clearly 4/5 is bigger than 2/9. It's not less than. So I think we can eliminate answer choice D, which we can. Gone. Okay, so it's either A or C. Okay, I kind of skipped over C just because like I'm looking at those and I'm like, oh, those are kind of close.
Yeah.
Those are kind of close. Boy, if you were gonna guess, and maybe we can split these up. Maybe we want to do the rectangle thing for C.
Sure.
Let's do it. Why not? We got the time. And keep in mind, by the way, when you're taking the Accuplacer test, this is an untimed test. Totally untimed. Different from the SAT or ACT time, right? With that time constraint. Untimed, you can take all the time in the world. You can draw all the pictures you want. Like, please do it. You've got the time to do it. Think in concrete terms. So, all right. So we got 5/8 and 6/10. So I'm going to do some more rectangles here. Roughly equal size. Okay, good. I'm going to split that into 8. 8's a little bit easier because I can just go like, hold on. I'm just going to split it in half first and then split the halves into 4s. Okay. There we go. So 4s. Is that 8 parts, roughly? Roughly, yeah. And then the other one is 10. So I'm going to split that in half, and then 5 parts. Ooh, it's going to be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Ooh, not super accurate there, but we'll have a rough estimate. Okay, so let's do 5/8 first. So that's 5 of them. It's going to be right here. All that. Does that make sense?
Mm-hmm.
And then 6/10. Boy, that's going to be close. That's very close. That's tough.
Yeah.
That's tough. If you're going to guess which one's bigger, which one would you guess? 5/8 or 6/10?
5/8.
I think 5/8, just a little bit. especially considering like how big my three slivers are here compared to the, how small they are over here.
Mm-hmm.
In my imperfect drawing, 5/8 is probably a better guess. But and I think that's right. I think 5/8 is bigger than 6/10. I think it is. But let's see if we can prove it here. Okay? And we can compare these easily if we come up with a common denominator.
Mm-hmm.
Okay? So we're using that same approach that we used when we were adding the fractions together. Okay? So let's talk about that math operation. And by the way, I think it is answer choice C. We're going to confirm it here in just a moment.
Mm-hmm.
But we could confirm it again, just using drawing the pictures and using that basic estimation. But let's confirm it with the math. So if we've got 5/8 and I want a common denominator to compare it to 6/10, what's my common denominator going to be? How am I going to find that common denominator?
I think it would be 80, so you would multiply it by 10.
Yeah, we could make it 80. I think we could also make it 40, but let's make it 80. I think it's going to make it easier if we make the common denominator 80.
Yeah.
So we'll just multiply that. We'll multiply 5/8 by what?
10.
10 over 10.
Over 10.
Right? And it's the same thing here that we did last time. Right? Those parentheses, by the way, mean multiplication. So it's the same thing as last time. 10 over 10 is equal to what?
1.
It's equal to 1, right? So we're not changing the value of 5/8, we're just changing the form. And then when we're multiplying fractions, we multiply across the numerator and across the denominator. So what do I get in the numerator?
50.
50 over what?
80.
80, right? Because 10 times 8 is 80. So we got 50 over 100. Or sorry, 50 over 80. Good. So that's for 5/8. And then let's find 6/10 here. So 6/10. How am I going to get a common denominator of 80 here?
Multiply both by 8.
We're going to multiply both by 8. Or multiply it by 8 over 8. Right? And what's 8 divided by 8, by the way, Juliana?
1.
1, right? So we're not changing the value of 6/10 because we're multiplying by 1. We're just changing the form. What is 8 times 6?
48.
48, absolutely. And what is 8 times 10?
80.
80. There we go. Ooh, that's close. Right? That's really close. Which one is bigger, by the way?
50 over 80.
50 over 80 is bigger because you've got the same denominator, but you got a bigger number in the numerator. So we can confirm it is indeed answer choice C. Ooh, that's really close. And that's again, why it was tough to figure out with visual estimation, right? Mm-hmm. Because those are so darn close together. But it is indeed answer choice C. I want to look at answer choice A real quick. I just want to see if we can eliminate that one. And let's do the same step. We'll do it one more time to see if we can compare those fractions. We'll come up with a common denominator. Okay. What's our common denominator going to be for answer choice A? What's our common denominator going to be?
I would say 28.
You do 28. And here's a little trick. Here's a little trick for coming up with common denominators. You don't have to do it, but it makes it really easy. If you just multiply the denominators, you'll get a common denominator. If you multiply 4 times 7, 28. There's your common denominator. We did the same thing with answer choice C, right? Just multiply 8 times 10, you get 80. There's your common denominator. It may not be the lowest common denominator, okay? Like we said, we could do 40 for answer choice C. Because 8 goes into 40 and 10 goes into 40. You can do 40, it's fine. But you're going to get a common denominator if you just multiply the numerator and denominator. And that'll be your common denominator. So to get a common denominator of 28, what do we have to multiply 3/4 by to get a common denominator of 28?
7.
7 over 7, right? Not multiplied by 7. 7 over 7. I know what you mean, by the way. Mm-hmm. But I just want to make it really clear for anybody watching the recording. And what does that give us? Let's multiply the numerator. What do we get? 7 times 3 is what?
21.
21. What's 7 times 4?
28.
28. So that's 21 over 28. And then let's look at 5 over 7. What are we going to multiply that by to get a common denominator of 28?
4 over 4.
Yeah, absolutely. 4 over 4. Again, 4 over 4 is just 1, so we're not changing the value. We're just changing the form. What's 4 times 5?
20.
20. And what is 4 times 7?
28.
28. Bingo. Ooh! Which one is bigger, by the way?
21 over 28.
21 over 28 is bigger. So 3/4 is the bigger one. Which is why answer choice A is wrong.
Yes.
Right? Because 3/4 isn't less than 3/4 is bigger than 5 over 7. So we can confirm indeed it is not answer choice A. It's answer choice C. Any questions about that?
Nope.
How confident do you feel that it's answer choice C, that we did this the right way? Again, I don't have an answer key in front of me, but how confident do you feel that it's answer choice C?
Pretty confident.
Pretty confident, right? Because we did two things. Well, first of all, we solved it in two ways, right? It's kind of basic logic and estimation. And then we did the math operations. But we also eliminated all the wrong ones and confirmed the right one.
Mm-hmm.
You can feel very confident about your answer choice if you've done both those things. Confirmed the right one and eliminated all the wrong ones.
Yes.
And you've got the time to do it on this test. It is an untimed test, so do it. Always test answer choices. Always use that process of elimination. And then you know you're on the right track. All right?
Mm-hmm.
Let's do some more. Ooh, question number 18. Go ahead and read this one for us, please.
If 3/4 divided by 1/6 equals p, then the value of p is between which of the following pairs of numbers?
Okay, so we are not adding fractions here. We're not multiplying fractions here. Not yet. We're going to. We're dividing by fraction. All right? We've got a fraction, 4/3, that's being divided by another fraction, 1/6. Okay? Now, this is one of those things where I'd love to say, like, well, let's just think about it logically and estimate. It's not obvious to me. If I've got 4/3 of something and I divide that into 1/6, how much is going to be that? That's not super obvious to me. You kind of got to know the operation. You got to know the thing to do when you're dividing by fractions. Juliana, do you know how to divide by fractions?
I think I remember.
Okay.
Hopefully.
What do you think it is?
I'm thinking you would flip the 1/6 to the reciprocal and then you multiply.
Yes. When you're dividing by fraction, and here we're dividing by 1/6, there's a simple operation. Just know it. You multiply by the reciprocal of that fraction. And when we say the reciprocal, you just flip the numerator and denominator. So if we're multiplying by the reciprocal of 1/6, we're multiplying by 6/1. Because that's the numerator and the denominator flipped. Does that make sense, Juliana?
Yes.
So let's rewrite that question. And just knowing this, we're going to get it. We got 4/3, and dividing by 1/6, we're multiplying by the reciprocal of 1/6. It's 6/1. And remember, when we multiply fractions, you multiply across the numerator and across the denominator. What is that going to give us?
24/3.
24/3. Absolutely. Do you know what 24/3 equals, by the way?
8.
Yeah, it equals 8, right? 24 divided by 3 is 8.
And I know the answer, too.
And I think you know the answer. Absolutely. What's the answer here? What's the answer?
D.
It's D. It's D. Right? Because 8 is between 7 and 9. Any questions about that?
Very simple.
Very easy. Looks a little bit intimidating at first, right? It looks like there might be some algebra. There's no algebra here. They just want to see if you can divide 4/3 by 1/6. But again, just remember, when you're dividing by a fraction, multiply by the reciprocal of that fraction. And then you got it. Any questions?
Nope.
Okay. Well, I got some more questions for you. Let's keep rolling. Hey, word problem. Word problem. With fractions.
Of course.
Okay, yeah, of course. All right. But it's doable. I promise you it's doable, especially, we're going to approach it with some basic logic here. We're gonna figure this one out. Go to read question 20 first, please, loud and proud.
Carol works at a bookstore and a restaurant. In a 28-day period, Carol worked 1/4 of the days at the bookstore and did not work 1/14 of the days.
Stop. Okay. Before we finish the question, and before we even find out what we're solving for, we're going to find out here in just a minute. This is one of my favorite strategies on word problems. When they give you a chunk of information, they give you a healthy chunk of information here in this first 2 sentences. When they give you a chunk of information, see if there's something you can solve for with that chunk of information. Does that make sense?
Yes.
Because you're probably going to need that thing, whatever it is you're solving for, you're probably going to need that thing to solve for the thing they're asking you for at the end of the question. I can almost guarantee it. Okay? So, if there's a 28-day period and she worked 1/4 of the days at the bookstore, how many days did she work?
3.
What are you basing that on? Where'd you come up with the number 3?
Off of 7 days a week.
Well, we're talking about we're talking about a 28-day period.
Oh, never mind.
Right? And she worked 1/4 of those days. Think about it for just a minute. She's working every other day. Or not every other day. I mean, every 4th day. I mean, in theory, you could like create a calendar. Right? You know what I'm saying?
Yeah.
I'm tempted to do. Are you okay with doing it?
Yeah.
Let's do it, because I'm just such a fan of making things concrete. Again, like, forget about math. Forget about, like, oh, what's the step? What's the thing I'm supposed to do? Like, we're going to cover that too. But you can use your common sense here. Let's make it. I'm doing it. I am freaking doing it. I'm making a 28-day calendar. I'm going to create some space here. Okay? We're going to make a 20. And this is exactly how you need to approach the test. Okay. So I've got a 28-day calendar here. Very ugly calendar. So I'm going to try 7, 1, 2, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Okay. And I'm splitting that into 4 weeks. Beautiful. Right? Is that 28 days?
Yes.
I think so. Yeah. Right. Here's Monday. I don't even know if we need to get that specific. Monday, Sunday. I don't know. I know what's calendar be with Sunday, whatever. I don't know.
Yeah.
Deal with it. Okay. That's going to be fine. All right. So she's working every 4th day, or 1 out of 4 days. So just start. I want to see you do this. Like, start marking off 1 out of every 4 days. Let's assume it's open, every day of that 20-day period.
There we go.
I'm going to stop you real quick. Can you do me a favor and undo what you just did? Just press undo. I think you're on the right track, but I want to make this real easy. Okay.
Mm-hmm.
Let's just assume she's working the first day out of every 4 days. And I'm going to label this. She's working at a bookstore, right? So we're at the bookstore.
Yes.
So that's 1 out of the first 4 days. Then the next 4 days, I'm just going to keep it regular just to make it simple.
Mm-hmm.
Then that's the next set of 4 days. There's the next set of 4 days. Right? You see I'm doing like these 4-day chunks?
Yeah.
Right?
I think I was doing 5 days on accident.
Maybe. I'm not sure. I was having a hard time adding it up, but I think we're on the right track now. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Does it make sense how this is 1 out of every 4 days? 1, 2, 3, 4. 1, 2. Okay. I think that's right.
Yeah.
There we go. Ooh, there's a nice little geometric pattern there that kind of popped up there. Anyway, how many days is she working at the bookstore?
7.
7. And that's right.
Mm-hmm.
And that's right. Okay. Now, let's talk about the math operation, because it's worth knowing too. Okay? If you want to find the fraction of something, like what fraction is working 1/4 of the days of a 28 period, if you want to find the fraction of something, just multiply the original value, here in this case like a 28-day period, and we want to find 1/4 of it, multiply it by 1/4. Multiply 28 by 1/4. And that'll say what the fraction is. So let's do that real quick. So we've got 28. I'm going to turn 28 to 20/1, just because we're dealing with fractions, adding or multiplying. Here we're multiplying, but I like having a clear numerator and a clear denominator. All right, 28, by the way, is the same as 28/1, in case that's not super clear. Okay. All right, so we're multiplying 28 by 1/4. Again, you multiply across the numerator, multiply across the denominator. What does that give us?
28/4.
28/4, and what's 28 divided by 4?
7.
7. Very simply.
That makes more sense now.
That's what you needed to do. Yeah. Now, of course, again, we found that by just like drawing a calendar and counting it up. I think I like the first method better.
Yeah.
I'm not gonna lie, because like you're not gonna mess it up as long as you you mark it properly.
Yeah.
You're gonna get it right. There's no math operation to screw up though. You know what I'm saying?
Mm-hmm.
Okay. Let's go to the second part though. She didn't work 1/4 of the days. Or 1/14th, I'm sorry. 1/14th of the days. Maybe you could tell me right now, if she didn't work 1/14th of the days, how many days did she not work?
Doing the math.
Well, I'm just thinking logical terms here. Every 1 out of 14 days she doesn't work. So go back to the calendar. Look at the calendar. Just pick 2 days. Right? I'm just going to put a big X.
Mm-hmm.
Days she didn't work. Does that make sense? Right? Because that's one out of, here's the first set of 14 days. 1 out of 14 days she doesn't work. Here's the second set of 14 days. 1 out of 14 days she doesn't work. So it's 2 days out of the 28 she doesn't work. There you go. That's good enough for me. Now again, we could do the math. We could do the math operation. Let's do it. If we want to find 1/14 of something, what do we do? If we want to find 1/14 of 28, what do we do?
We do 28 over 1 times 1 over 14.
Times 1 over 14. There you go. Multiply across the numerator and denominator. What do we get? 28 times 1 is what?
2 days.
Yes, but what's let's go through the steps of what's 28 times 1?
Oh, 28.
28, right. You're jumping right to the answer. You're right. And then 1 times 14 is just 14. Right. So, yes, 28 divided by 14 is just 2. Right. But again, we solved that kind of using some basic logic and just kind of drawing it out on the calendar. Does that make sense?
Yes.
Okay. Any questions before we move on? We good? No? Okay. Now it says, on the remaining days, Carol worked at the restaurant. That's the next part. Well, we got the calendar here, man. Yeah. We can just fill it in. On the remaining days, she's working at a restaurant. So I'm going to do it. I'm going to fill this in. R, 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 R. My handwriting's getting worse progressively. Apologize. R. There we go. And read the last sentence of the question.
On the remaining days, Carol worked at the restaurant. How many days did Carol work at the restaurant during the 28-day period?
We just count them now. Right?
Mm-hmm.
We just count them. How many? What's the answer?
19.
5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 days. What's the right answer choice?
B.
Answer choice B. Bingo. We got it. Without doing a whole lot of math. We got it.
Mm-hmm.
We got it. Now, if you're doing the math, like what's the right way to do it? I mean, I can show you, I guess. I mean, we found, well, I mean, like we're not far from it, right? Because we already knew just by calculating the first part, by knowing that she worked at the bookstore for what? How many days did she work at the bookstore?
7.
Yeah, she worked at the bookstore for 7 days, and she didn't work for 2 of the days, and then she worked the rest of the days at the restaurant. So it's 28 minus 7 minus 2, which is 19. So I guess that the math's not complicated either. Yeah. You can find out what fraction of the days she worked. I mean, you can make this more complicated, but don't. Don't. Keep it simple. I like the calendar method.
Yeah.
Never done it that way before, but I like it. I felt inspired. I think it works out pretty well. All right. You have any questions? No? Okay. Let's do some more. We'll take a little break here in just a couple minutes. Let's see if we can get some more questions done. Ooh. Oh. Question number 11. Read it for us, please, Juliana.
Which of the following is equivalent to 8 over 25?
Oh. This is the kind of question that throws a lot of students off, man. A lot of students. Okay. And I get it. Let's talk about the weight of these values, though. All right. I like that phrase. Weight of these values. Okay. And again, I've seen questions like this on Accuplacer tests. I anticipate seeing an equivalent expression question like this. You got to know kind of what fractions equal in terms of decimals and vice versa. If you were going to estimate roughly how much 8 divided by 25 is, or 8 over 25, what is that roughly? Give me an estimate.
About like 0.30.
0.3. I agree with you. I agree with you. If there's a fraction that's close to 8 over 25, what fraction is that?
10 over 25, approximately.
Maybe 10 over 25. That's one way to think about it. I I'm looking at the 8 over 25. It's close to 8 over 24, right?
Oh, yeah.
You know what I'm saying? Like, and I know what 8 over 24 is. What's 8 over 24?
1/3.
1/3, right? 'Cause 8 divided by 24 is, 1/3. 8 goes into 24, 3 times, so 1/3. Does that make sense? I'm just kind of feeling out how much that value is.
And then is it 1/3, 0.3?
1/3 is darn close to 0.3. Yeah. 1 divided by 3 is like 0.33333. We'll talk about why in just a minute. But that's close to a third. Okay.
Yeah.
Well, let's look at the answer choices. If you are going to eliminate some answer choices, what answer choices are you going to eliminate?
D.
D is crazy, right? And why is D so insane?
Because it has a number in front of the decimals.
Yeah, which means that that's over. Answer choice D is that 3.125. That's more than 3, right? And here we're talking about a fraction that's less than 1, right? I've got this question from students before. How do you know if a number, if a fraction is bigger than or less than 1? Real simple. If the numerator is smaller than the denominator, for example, like 1 over 100, right? The numerator is much smaller than the denominator. In that case, it's less than 1. In this case, a lot less than 1. Okay? But if the numerator is bigger than the denominator, like 3 over 2, that's bigger than 1. Because 3 divided by 2 is, bigger than 1. It's like 1.5. Or like, maybe a more obvious example would be 4 over 2. Right? That's a fraction. 4 divided by 2, it's also a number, 2. So when you divide 4 by 2, you get 2. 2 is bigger than 1. So if the number in the numerator is bigger than the number in the denominator, it's bigger than 1. Does that make sense? Okay. So here, clearly we've got a fraction 5 over 28, 8 over 25, which is less than 1. And answer choice D isn't less than 1. It's a lot bigger than 1. So, it's bigger than 1, we'll say. Any other answer choice you would eliminate if we're talking about process of elimination here?
C.
Yeah, C. Why C? Tell me why.
Because C is just the decimal of the fraction.
Yeah, and C is a great example of a question that they're basing some of these answer choices on like common misconceptions about math. And like a lot of students are going to look at like 8 divided by 25 and be like, oh, the answer choice. Oh, there's an 8 and a 2 and a 5 in the answer choice. Oh, it's got to be C. Come on, no. No. Doesn't work like that. And again, think about the weight of the values here, Juliana. Think about the weight of the values. Right, like 8 divided by 25 is close to a third, but 0.825 is closer to 1. Does that make sense? Why?
Yeah.
I've had some students that really struggle with decimals and like thinking about what decimals mean. And what I always coach them to do is think in terms of money. Like if you're not sure how much this is, those 3 answer choices, how much they are, what they mean, think in terms of money. Right? Like make 0.02, make that 2 cents. You know what I'm saying?
Yeah.
Make 32, make that, or 0.32, make that 32 cents. And then that 0.825, make that like roughly 83 cents. 82 and a half cents, whatever.
Yeah.
Right? Well, which of those is close to a third of a dollar? Because remember, 8 over 25 is close to a third. Which is close to a third of a dollar?
B.
B. That's right, B. Absolutely. Right? A is silly. This is like 2 cents. Yeah. It's nothing. C is too big. That's too close to a dollar. We're talking a third of a dollar. It's got to be answer choice B. That's without doing a single mathematical operation.
Yeah.
Now, was answer choice B pretty obvious to you, maybe right off the bat?
A little bit,
Because you felt pretty, you were like, oh, that's going to be like 0.3, so it's got to be B. Yeah, that's kind of what you're thinking. I want to practice dividing a little bit. I don't know to what extent. I don't know if they would give you a calculator on this question on the Accuplacer. It's possible. I don't know. I'm guessing maybe not if you had to answer this one. I'm guessing you wouldn't have it. But let's practice divide. Can we divide 8 by 25? Do you know how to do that? Can I see you work that out on the whiteboard? I'd like to see it. I'll guide you through it. Do you remember your division? Remember how that works? Yeah. Great.
Yeah, I just plugged it in my calculator a second ago.
Yeah. And you write that, okay, so you plug in the calculator. I'm talking like writing this out division-wise. Do you know how to do that? Like, how do you divide 8, by 25? Do you know how to do that? Is that familiar or no?
Kind of.
Let me do it. I'm gonna show you how to do it. And again, I think the best way to answer this question is to feel it out and use some estimation. But let's review, the steps of division here. So 8 is the same as 8.0, and I'm going to need the decimal up here.
Oh, I remember this.
Right, because the question is, how many times does 25 go into 8? And it doesn't go. I mean, it just doesn't fit in. So I've got to turn that into 80 or 8.0. How many times does 25 go into 80?
3.
3 times. Not more than 3 times. If it went 4 times, would be 100, but 3 times would be 75. So you multiply the 3 times 25, and you get 75. Subtract them. Right? Is this familiar?
Mm-hmm.
Thank you.
Yeah.
Right, and then 80. What's 80 minus 75? 80 minus 75. Yeah, 5. 5, absolutely. 5. Another 0 here, right? Because 8.00 is same as 8. And then how many times does 25 go into 50?
2.
2 times. So 0.32. I'm not saying you're going to have to do that on the Accuplacer. I'm guessing it's not going to be necessary. But if you wanted to confirm it and feel really comfortable about it, and you're familiar with this form of division, then that's kind of the way to do it. I wouldn't freak out about it if you...
It's coming back to me now.
Yeah, I wouldn't freak out about it if you're not, and if you need to do a search on YouTube for dividing numbers, dividing decimals, or whatever. I mean, if you need to, I don't think it's going to be necessary because you can just find the answers thinking in concrete terms if you know what decimals mean.
Yeah.
Right. If you know what they mean. Any questions?
Nope.
Okay. All right. Let me look at the next question real quick.
Oh, goodness.
Let's do this one real quick, and then we'll take a little 5-minute break. Go ahead and read question number 6, please.
What number in the list above has the greatest value?
Ooh. What number on the list above has the greatest value? Well, that's a good question, isn't it?
Yeah.
That's a good question. Do you think you know the answer to this, Juliana?
It's not completely obvious to me
at
the moment.
Well, I tell you what, let's get rid of the smaller ones then. Let's do process of elimination.
Mm-hmm.
Are there any that are probably not the greatest?
I'm thinking D. Maybe.
Yeah, I would eliminate D right off the bat. Absolutely. Why can you eliminate D?
Because it's so small.
It's so small. Right? 0.199? I know you might be like, well, that's 109. It's not 199. It's 0.199. Right? And so again, if you need to think in terms of money, think in terms of money. That's like 20 cents. Mm-hmm. 19.9 cents. Think about it in terms of money. 19 cents. Compare that to answer choice B.
Yeah, that's a lot of money.
$2.28. I mean, I know it's a lot of money, but I mean,
it's a good amount.
It's a fair amount. Yeah, it's more, you can't buy anything with 19 cents. You can buy something with $2.28. Does that make sense? Why we can obviously eliminate answer choice D. Just thinking in kind of estimation and kind of concrete terms and basic logic. It's not D. But I think now I know we can eliminate another answer choice very easily. Very easily. What other answer choice can we eliminate? Easily.
C?
I think C. Why can we eliminate C? You're absolutely right. Why?
Because that's going to be a pretty small decimal.
It's going to be less than 1. It's going to be less than... Why do we know C is going to be less than 1?
Oh, because when you simplify it, you can automatically tell that it's going to be near 1.
Yeah, I mean, it's near 1, but it's not as big as 1. But let's think about the rule that I told you before. If the numerator is smaller than the denominator, if the top's smaller than the bottom, right, that's going to be less than 1. And again, let's think about that 10 over 12 in concrete terms. You've got a piece of pizza. You've got a pizza that you split into 12 slices.
You have more than half the pizza.
You got more than half. But if you've got 10 out of the 12 slices, you still have less than 1 pizza.
Yeah.
Right? You've got 10 out of the 12 slices. Don't know, that's a lot of pizza. 10 slices? That's a lot of pizza, okay? But it's less than a full pizza.
Mm-hmm.
So it's less than 1. And look at answer B. Again, it's clearly more than 1. It's more than 2.
Mm-hmm.
So C's got to be smaller, which it is. Okay? Does that make sense?
Yes.
If at this point you're just guessing, you have a 50-50 shot. And those are pretty good odds. This is not an easy question. Okay? It's not an easy question. How are we going to tell how are we going to tell which one's bigger, A or B? How are we going to tell?
Putting the A into a decimal form.
Yeah, we turn A into a decimal form. Absolutely. I don't know how to put B into a fraction form. I don't know. I'm going to mess with that. I mean, no, I'm not going to do that. I'm not going to do it. I'm not going to do it. But let's turn A into a decimal form. And that's why I think we're going to have to do that division operation. Is going to be helpful here. Do you think you could do that now? You could set that up. Could you divide 8 by 3?
Yeah.
Let me see you do it.
I can try.
Let me see you try. I'll guide you through it step by step. Don't worry. Give it a whirl. Looking good, looking good. Yep, it goes into 3 goes into 8 2 times. 8 minus 6 is 2, right? And this is where like that whole decimal thing. Yep, you gotta have that decimal right there, right? Because 8 is the same as 8.0. Drop the 0.
It's just going to be repeating.
Yeah, I want to see you carry it out though. I think you're absolutely right.
Mm-hmm. Do I put the 8?
Yeah, you're going to drop the 0 down here. Oh no, stop. Yeah, you're going to just drop the 0 down here, and it's 6. Oh, it is. Wait, what? There you go. Yeah.
Numbers.
Yeah, there you go. 20 minus 18, absolutely. And that's where you're going to need another 2, and it's just going to repeat. I think. Did we do this right?
I think so.
I'm questioning my division now. Goes into 6.
Yeah,
Oh yeah. That's right.
Right.
That's right. We did it right. Yep. Okay.
Yeah,
good.
I plugged it into calculator and I got 2.6.
Yep. And then you drop it again. It's just going to repeat forever. Yeah. But once you got 2.6, I mean, you don't have to do this like 12 times or anything like that. Like once you get 2.6, 2.6 is bigger than 2.28.
Yeah. So A is the right answer.
So it's got to be A. I guess another. Yeah. That makes a ton of sense. I'm trying to think about it in like concrete terms. What 8/3 of $1 is. I don't know how to think. It goes into. Now this is probably the best way to do it. But we know it's not C or D at the very least. We know it's not. And we can confirm it is indeed answer choice.
Mm-hmm.
Answer choice A. All right. Any questions about that? Yes or no?
Nope.
No. Okay. Let's take a little 5-minute break. Go and run to the restroom. I'm going to get some more coffee.
Yay.
And probably go to the restroom too. And then we'll pick up with some more questions on
food.
Accuplacer arithmetic here in just a moment. All right? I will see you soon. Thanks, Julianne.